Okay, so now I hope that you already have the rough idea how to sketch the modulus function graph and also how to write out in a non-modulus form. Okay, all those are very basic. All right, and then now you are going to use all those concepts to see to answer some question. So let's have a look for example 2 here. This is what we have for example 2 in our notes. Okay, so before we start the example, right, I want you to correct the typo here. This is the typo that I made before. I already changed it up. So your original file is modulus ax plus b, right? Actually, the a should be outside. Follow the graph. Follow the graph, right? So the same thing happened here. Okay, so for this particular question, they give you two modulus graph, and then from here, maybe you need to answer the question. Right, so let's have a look here. They give you these two functions, modulus function, and they said the y equals to a modulus a plus b. They got x and y intercept. These are the x and y intercepts value. Okay, so first part, they want you to find the value for a and also b. All right, so for this equation, y equals to a modulus x plus b. Okay, so to find the a and b, you need to solve simultaneous equation, right? So by using the point that they give you, okay, you can start from here. So at the point -1 and 0, that means your y is equal to 0, a is a, then this one you're having -1 plus b. Okay, so for any value here, a is a -1 plus b is also a value, right? So what value times what value, then you can get a 0. So there are two possibilities. That means to get a 0, your a equals to 0, or your -1 plus b equals to 0. Correct or not? So that you can get a 0 here, either one. Alright? Okay, so -1 plus b equals to 0. I no need to put modulus anymore because 0 is a 0. It is not positive, it is not negative. So I can remove the modulus function straight away. Okay, and therefore my b is equals to 1. Okay, alright, so please take note that these are not the final answer yet because of, if you look at this, a equals to 0, although it looks like it is the answer, right? But actually this is not an answer. You should ignore it. Why you should ignore the a equals to 0? Because if you look at this one, when a equals to 0, that means the whole thing is y equals to 0. If y equals to 0, you won't have this graph. Understand what I say or not? So a cannot be 0. Therefore, I need to ignore this value. So I'm having one value only here, which is b equals to 1. And this is the correct one. Okay, then from here, I need to continue to find out the value of a. Okay, so how can I find out the value of a? Then you use the other point. So the other point is a at 0 and also half. Okay, so y equals to a modulus x plus b. Your y is half. A, you don't know what is the value. X is 0. Therefore, you are having a b here. Okay, so from the first equation, your b equals to 1, right? That means you put in the half equals to a and then modulus 1. Modulus 1, it is still a 1, correct or not? Therefore, you have a equals to half. Therefore, this is the answer for the a. Okay, all right. So all this modulus sign, when you want to solve it, right, for this kind of question, you might need to think a little bit. When it is equal to 0, you can remove the modulus sign straight away because 0 is not negative, also not positive. So the modulus sign will not affect anything. And then when you are having this kind of equation, like modulus 1, 1 is a positive value. All right. Therefore, when you're having modulus 1, it is still a positive value. Therefore, it is still a 1. So you have a equals to half. So this is how we solve this part A, part 1. Okay, all right. Then now we can proceed to part number 2. Okay, so for part number 2, they want you to find the coordinates of the 2 points of intersection of the graph. Okay, so maybe before we start, what I want you to have a look is this one, to save our time. Okay, so your answer for y is y equals to half, then modulus x plus B. Okay, so if you look at modulus x, the gradient originally is positive, right? Positive x, correct or not? So when you're having a positive x, that means your original graph is this one. And after that, this is the reflected part. Okay? Alright, then the same thing happened here. When you are having y equals to modulus x, where is the reflected part and where is the original part? So again, this is the reflected part. Sorry, this is original part. And the reflected part is this one. Okay, so for the reflected part, you should know that this is y equal negative x, or correct or not? Okay, then for this one, the reflected part will be y equals to half, and then you're having negative x plus b. You put a negative in front of the modular sign, right? Okay, so this is the reflected part. Then the original part is y equals to half, and then x plus b, or x plus 1, I should write. Okay, so usually when I want to use the graph to help me and solve the equation, right, usually I would prefer to check out first which one is the reflected graph and which one is the original graph. And I will label it out clearly. Okay, then now we want to solve for the equation, right? Okay, the intersection point. So when they want you to find out the intersection point, before I solve it, I will see the point first. So where is the first point? This is the first point here. Let's say I assume that this is the first intersection point. If you look at this intersection point, it actually intersects at one original graph, this one, and also the reflected graph, this one. So when I want to solve it, what I do is I will let y equals to y log. So that means I will let negative x equals to half x plus 1. Okay, because from the graph I can see very clearly intersection point is intersect between this original graph and also this reflected graph. Therefore, when I want to solve it, right, I will surely write out the reflected graph, negative x equals to the original graph. Okay, then the same thing happened here. Let's say I want to look for the second intersection point. So this is the second intersection point. If you look at this second intersection point, very obvious that both are reflected, both are intersect at the original graph. So this is the original graph, and also y equals to x is the original graph. Okay, so when I want to solve this blue color intersection point, what I will do is from the graph, I know that it is x equals to half x plus 1. Okay, so from here, only I continue. Okay, so before I write out the equation to solve, right, I will look at the graph to help me and decide which is the correct line first, which is the correct equation. Okay, then now, to solve this one, I think this one is very easy. Now you can try on your own before you check the final answer here. Okay, so the very first intersection point that I get is negative 1 over 3 for the x and also 1 over 3 for the y. So if you want to double check your answer and see, you can look for the graph again. So you can see that negative 1 over 3 and 3. I think the location is quite matched up. Alright, so this one is negative 1 over 3 and 1, negative 1 over 3 and 1 over 3. Alright, so that means this intersection point is correct. Okay, then now we can check for the second point here, second intersection point. So if you solve it, this is what you have. Okay, so you should still have half x equals to half, and then you're having x equals to 1. And then y equals to x, right? Y equals to x for this, so y equals to 1. And therefore this intersection point is 1 and 1. So if you want to check and see whether your answer is it in the correct side or not, then you look at the graph again. So again, this blue color graph, if you get 1 and 1, which is quite logic also. But if you look at the graph also, it is very near, very close to 1 and 1. Okay, so that means when they are drawing this graph, they are drawing it by using a proper scale. Alright, so therefore, if you want to solve the question by using graph, right, you better draw it up on the graph paper. Okay? Yeah, so I understand that this is a bit new to you, but actually not very complicated. Just that before you solve for the intersection point, you need to look at the graph first. Okay, which this intersection point is intersect with which one and which one. And then you need to know this particular graph is reflected, therefore you need to put the negative in front. Okay, then the original one, you don't need to put the negative in front. Okay, so I hope that you have some basic idea on all this. Okay, so again, if you are free, try to follow and complete the example or exercises that I asked you all to attempt. Okay, all right, so this is what we have for this video for today.